Good afternoon, distinguished colleagues. Theophilus, I can see you. Omobola, Omolabake. Koyum, are you there? Kolawole.
Yes, sir.
Yes, sir.
Karim is there with you, sir.
I can see Theophilus, a very...
Yes, sir. Good afternoon, sir.
Yeah, a jolly friend. Olajumoke, now we have you today.
Good afternoon, sir.
How are you?
Very well, thank you, sir. And you, sir?
You can see me. Do I look well?
You look very well, sir. Well fed.
Really?
Yes, sir.
Nobody told me this. Nobody told me. Okay, I will register that. Moso is coming from a legal perspective. So, Junaid, how are you?
Hi, sir. Good afternoon, sir.
Good afternoon. David Olawi have joined now. Emmanuel Ode. These are great minds. Unfortunately, we rarely have the opportunity to meet in person. I don't know how many of you have met or how many of you met me, but we'll make sure we make it possible for us to meet. So it's good to have you. Time flies, and no, it doesn't wait for anybody. Now I got a notice that your exam will start maybe first day of September. So is that a good news? Is that a good news? Nobody is responding.
Yes, sir. For me, it is.
Yes, sir. It's a good news, sir.
It's a good news, right?
Yes,
Yes,
sir.
sir.
Okay. Suppose we recommend that we bring it forward. Will it be a good news too?
We are well able.
You are well and able. If we bring it to August, maybe mid-August.
Yes, sir, but God forbid.
Wow. Nothing concerns God about this matter. It's for us to decide. So Okay, so I think we have a good number to start the business of the day. And as usual, uh, I hope those who will record will record. If not, um, uh, so okay, so we are now being recorded. So good afternoon once again, and thank you for taking the time to join this lecture. Um, Possibly this will be the last meeting I will have with you, regarding this course. But that does not foreclose or no, doesn't mean that we cannot talk or discuss or engage ourselves on any aspect of the course, anywhere, anytime, any day. So today we will start with the usual review of what we discussed last week. I want one or two or three people to quickly take us through the memory lane, and then I will let you know what we have today, uh, and then we hit the ground running. So who are the volunteers? Do I call names or are there volunteers? Just a quick rundown or review or whatever you can remember from our last lecture. Yeah, I can't see anybody raising hands or volunteering. So if you allow my spirit to choose to let somebody. By the way, Olajumoke, why did we not see you last week?
Um,
We
I,
missed.
I, so I had a professional commitment that I could not get out of.
Okay.
Sorry, sir.
No problem. Next
Thank,
time, just invite me to handle the case for you.
thank you, sir.
Yeah. So you will take the class. I will go to court, and no,
Very well, sir. So long as we share the proceedings.
no problem. I mean, so
Amen.
I've been to court only once in my lifetime, and I pray never to be there for anything, for any reason. So, um, who is reviewing? Do I call Theophilus, who promised last week to always keep the rule? Theophilus, I'm back.
Okay, sir. Thank you, sir.
You're welcome.
We learned quite a lot of things last week, majorly about statistics, if I remember very well, and we also talk about some types of research, like correlational research, and that is where we talk about the relationship between two or more variables, not necessarily examining any causal effect between the two of them. Then one thing that kept resonating with me throughout last week was this longitudinal trend studies.
Okay.
When you observe same variables over an extensive period of time.
Yeah.
It could be a company or an entity that you are examining, but it goes beyond one particular period of time, to be for 3 or 4 or 5 years. And you also taught us about descriptive statistics. So when we chose descriptive statistics as part of our research design, because that is what last week lecture was essentially all about, and you told us that in descriptive statistics, you report your observation as seen. You don't tamper with the observation. You don't do any manipulation. It's not subject to experiment. It's just what you have observed, and you do basic operations like mean, median, mode, or you calculate the percentage of the variable concern. So those are the few things I can easily remember, sir.
Excellent. That's good. Let's clap for him. I mean, uh, if I were to be the president, I can also give you maybe $100,000.
I claim it, and GCON to compete with Tinubu.
Yes, I can just write the check for you if it will be, if you can take it to CBN, or I ask uh, our, our legal team um, to see how we can um, get it out for you. So you deserve that award. So thank you very much. Yes, Umukoro, what perspective can you bring in? Umukoro, I'm coming to you. Kalim, I'm coming to you. Umukoro, are you there?
Yes, sir. I'm here, sir. Sorry,
Yes.
sir, for clarity. Was the class last week or last 2 weeks?
You are not in the class.
Was it this last Friday or the upper Friday? Last 2 weeks or last Friday?
We couldn't meet last week, so that
Okay.
made it even, uh, necessary to have taken time to go through. So
Okay.
yeah.
Okay, sir. I just wanted to be clarified so that I'm sure I didn't miss anything last week.
You didn't.
Okay. I heard the last class we talked about statistics, different statistics, how we can interpret data, the cross-sectional data, longitudinal data. Talking about longitudinal data where you pitch indicators, talking about data that carries over a period of time. You get data for different variables for a long period of time.
Yeah.
We're talking about cross-sectional data, which could be for one variable over some period of time at some intervals. We also went to talk about regression and correlation. So we talked about when do we say something is correlated, and when do we say something is not correlated. We talk about the positive and negative correlation, where we say 0.7 and above shows strong positive correlation, 0.4 to 6 shows mid or medium positive correlation, and below 0.3 to 0.1 weak positive correlation. Then when there is negative sign, just as we have weak, strong, weak, negative correlation, strong or weak negative correlation. Then we also talk about regression. Regression, where we also make reference to talk about regression being a causal effect. This is causing this to behave like this. So many others, sir. Thank you, sir.
Thank you. So let's clap for him too. That's a good contribution. So because of our time, we can just yes. Is anybody yes, Omo Labake? Are you trying to say something?
No, sir.
Okay. So anybody say so? So let's move on to what we have. So we are building on that lecture. If you recall that we have been discussing research designs, different types of designs that you can utilize when building or when developing your research, or when you are planning your research. You need to from the beginning, you need to know what type of design you want to adopt. So in that lecture, the focus was on just a minute. So the focus was to look at different designs that you can adopt in your research. And my greatest desire is to see you now uh, uh, be forward looking as we discuss these designs. You begin to reflect on the one that you might end up adopting for your research. Or if you are already thinking of what study you will conduct, what area you want to focus on, then as we discuss these different designs, you can begin to look at the most appropriate one, the most suitable one for the kind of study you are interested in. But of course, you need to have a very good understanding of the other designs. I mentioned, last meeting that it's just your research is like you are building a house, and if you don't have a design for your house, it's difficult for those who will lay the foundation, who will put structure on it, to know how to go about it. So designs, are critical, to be able to have a structure that you know uh, that matches your goal and your needs. So we will be focusing on what we call the basic and the advanced experimental designs. We've looked at two. They are basic, descriptive research design, and then the correlational research design. There are a few more ones that are basic and a few others that are fairly advanced. But before we even talk of whether basic or advanced, the most important word here is experimental. Experimental. So we could have a study that is non-experimental. You could also have one that is experimental. I try to talk about basic or physical sciences, chemical sciences, biological sciences. Those who have background in that area, they know a lot about experiment. You could perform experiment with humans. You could perform experiment with animals, with objects, and so on and so forth. So even in energy, one could plan an experimental study, which should be very, very interesting. What I notice mostly here, people prefer to just go and collect data somewhere, go download data and use that. Yeah, fine, but the kind of result to get there, they are not as very original or very specific as in the case of when you conduct an experiment. So in experiment, what we will see what makes a study to be experimental and what makes it not to be experimental. So, but we will start as usual with sort of pre-lecture quiz questions. This is just to see whether you have some background already when it comes to this topic or not. So quickly, you type your answer in the chat menu. So you see whether you are right or wrong. Which of the following best defines experimental validity? Validity is ensuring that this result is not vague, is not that is scientific. So accuracy of statistical method, is it when the statistical method is accurate, or when the result is generalizable, when the findings are generalizable, or when confidence, when you have confidence that the observed effects are due to the manipulation of the variables, or when you are able to reproduce your data collection. I'd love to see your responses. Who is so sure of this, of the answer? I've seen some responses. Who is so sure of the answer? Aṣẹ́gun Adenuga, Umukoro, you seem to be winning this discussion. Share your perspective with me why you are going for D. Aṣẹ́gun Umukoro, yeah, quickly.
Okay, sir. Good afternoon, sir. Or good evening. So the thing here is the reason why I choose the is because reproducibility of data collection.
Yeah.
So, like you said, experimental validity. So
Yeah.
we have to be sure that if I go back to this particular place, this is the exact data that I got. So this is the way it is, and this is the way I got it. So that's it. I don't know how best to explain, but just for you to just that you know, even if you lose the data today, but you go back to collect the data another time, it is exact data that you got at that particular time you did your first data collection that you are going to get again at the second time. So that is why I choose this.
Okay. The correct answer actually is C. that
So I have a question.
go
So I have a
on.
question.
Yeah,
So you said experimental validity. So
yeah,
and understandably, you are performing experiment. But
yes,
here in C, it is stated that confidence that observed effects are
yes,
due to manipulation of variables. So that
yes,
means the data that are collected, they are being manipulated.
yeah. Don't the word
But the
manipulation.
question,
Yes, you need to understand. I know when people hear the word manipulation, they think in a corrupt manner. Uh, but the word manipulation is simply saying you in your design you have some variables that you can control and you have some variables that you cannot control. For instance, if somebody wants to experiment how I will react, or the class, let's use the class as the subject, how the class will how their energy consumption will change. So we can divide the class in how the energy consumption will change if their income, increases, or um, if more taxes are imposed on the energy product. So the class can be divided. One group may have their income increased, the other group may not have the income increased, they remain the same. And then you are able to, that means in that experiment, you are able to control income. So you choose, maybe in the group, you will increase the income by 100%. The other one, you will not increase their own. And then you keep them in the same environment, put them under the same band, maybe band A, band B, or whatever, band C, and see whether by introducing, maybe subsidy, or you increase their income, or uh, you use any instrument, to control, um, and see whether their consumption pattern will change or not. That's the sense in which the word manipulation is used. But we will still talk more about that. So let's move to the next one. Don't feel bad. What type of variable is manipulated? Yes, by the researcher in an experiment. What type of variable? Write your answer. Dependent variable, confounding variable, independent variable, moderator variable. Yeah. Theophilus, why are you choosing A? I'm coming to you, Olajumoke. Theophilus, why are you choosing A? Quickly, quickly, quickly.
Okay, in any experiment,
Yeah.
you have sometimes you have two variables in any
Yes.
experiment, and
Yes.
there is one you call the control experiment.
Yes.
That's when all the conditions are present, but the other one or two conditions may not be present, so that you can observe what changes it will bring. And
Uh-huh.
because it is susceptible to changes, that's what makes it dependent. That's why I chose A.
Okay. The issue is that it's dependent because that is the variable of interest that you are trying to monitor. That so in this example that I just gave, what am I monitoring? What is my subject of interest? Which variable is my subject of interest? energy consumption, because that's what I want to monitor. So that if I change income, I want to see what will happen to that consumption. So you can't control that one. Is that clear, Theophilus?
Yes, sir.
You cannot control that variable, but you are monitoring. That's your target variable, the variable you are trying to understand its behavior. So you can rule out that the correct answer is C, independent. So I don't need Olajumoke to. I think Olajumoke chose C, right? So
I did, sir.
what made you to choose C? Was it that you knew, or it was just
No, it wasn't. I just worked it out that whatever I'm going to manipulate has to be independent.
Exactly. So what that means is that the independent variable, we use another terminology. We call it exogenous variable, because it's determined outside. So the experimenter is the one who will choose the level of subsidy to give, who will choose the level of incentive to give, and then monitor how the consumer now react. So we will still also talk about that. So the correct answer is C. Number three. Number three. Which of the following is not a characteristic of a true experiment? Which of the following is not a characteristic of a true experiment? Random assignment, control group, observational measurement only, manipulation of variables. Is not a characteristic. So what are the answers? I need somebody to just explain the rationale behind his or her choice. Who is talking? Who is talking? Quickly, 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 time. Chris, you are not talking. Yeah, David, why have you chosen A? Random assignment. Chris Okoro, or Moot.
Okay, sir. I chose random because by the name random means there is uh, no intentional way. I'm just looking for the exact word to use of arriving at it. It's just picked at random. It's not. It's not. It's not. There's no special or intentional way of arriving at it. It just happened at random. It's by, you can say, trial and error. You just pick it by luck.
So you think there will be no randomness in the in assignees, treatment to subjects? Is that what you are saying?
Exactly, sir.
Okay, let's look at the correct answer. The correct answer is actually C. The issue is that you are not only focusing on observational measurement only. You are not focusing on observational measurement only. Your observational measurement is you observing the outcome of the experiment. So when you do that, even if you collect the observational measurement, you still have the goal of analyzing. So the ultimate goal is not to have observational measurement only, and then you close the experiment. No, your ultimate goal is to see how the variables are, causing one another. When you change one variable, you want to analyze how it affects the other variable of interest. So here C is the answer. Next one, a post-test only control group design is an example of which type of design? Maybe you have not heard of post-test, but we are going to discuss it. But I want to know, if you choose anyone, why you are choosing it. A post-test only control group design. That's a design we will talk about. Post-test only control group design. What example of design is this? What type of design is this? Is it a quasi-experimental? Is it descriptive? It is experimental. Is it correlational? Yes, what I don't mind your answer, we'll just choose, but be able to give. Yeah, David Olaoye.
Prof, this particular answer was just a gamble. I don't know. I just gambled.
So it's also good to gamble. Is there any offense in gambling, during the exam? But there could be from the religious point of view, gambling with money is an offense. But why is it not offense in the exam? Olajumoke, is there any reason for that? Why gambling is not a crime when it comes to multiple choice question? But
Because you're not really gambling.
okay.
You're guessing, which is different.
Okay.
And you could guess right. It's not really gambling. It's not really gambling.
Okay.
You're guessing.
Okay.
Because the stakes are not that high.
Oh. So if the stake is okay, the size of the stake will determine whether you are gambling or not. That's another part. Anyway, to save time, the correct answer is C. Is an example, a good example of experimental design. Why do we call it post-test only? You have a subject, maybe a group of people, right? You have a group of people, like this group of people in the class, and then you divide them into two, maybe group A, group B. Maybe you randomly assign people to A, another group to B. And then, so you have the A, you also have the B now. And then you apply, you apply a test. let's say you subject them to different condition. One is a control group, the other you apply treatment to that, and then you now after the intervention, you now conduct a test to be able to see whether this group is different from this group as a result of the treatment you have applied to one. So it's a typical form of design, to be able to see whether the intervention is able to change things or not. We'll still talk more about that. So it's an example of experimental design. There's yet another design we will talk about, repeated measures design. When are they useful, or what are they useful for? A, reducing sample size. B, controlling time-based confounding. C, increasing internal validity. All of the above. In all of the above. Terry, why have you chosen all of the above? Is it because I kept saying all of the above?
No, sir.
Okay.
Well, I feel if an experiment is being repeated, it is a way of trying to verify if the previous result is consistent with future results, sort of.
Okay. Again, you guess if we are not going to use.
I disagree.
So Theophil, who disagree?
I'm not guessing though.
But you are not able to convince us with your argument.
I don't think repeated measures will result to reducing sample size.
So, okay, we will still discuss all but the correct answer is D.
Thank you.
The correct answer is D. The only thing is the argument is not strong is not strong enough to justify the choice. Number 6, which of the following statement best? Yes, Elisha Ojo Bello, quickly. Elisha, are you intervening?
No,
Okay.
no, that was a mistake, sir.
Which of the following statements best describes quasi-experimental design? They use random assignment, they eliminate all confounding variables, they lack full control over the assignment or manipulation of variables, they do not involve any intervention. Quickly, what is your C? Terry is choosing C. Yes, who else? You can guess. There is no crime in guessing. It's like majority is going for C. So C is correct. Clap for yourself. But whether your justification, is strong enough is left to you. We'll talk about that. Which is an example of a complex design. Except you are very advanced, maybe you will know. Which is an example of a complex design. Example, is it one group pre-test, post-test, randomized control trial, factorial design, case control study? Which one is an example of a people are not submitting their responses? Kwayum, okay, why have you opted for factorial design? Kwayum.
Basically, it's just because of my, I don't know, it's just guessing. But then factorial a combination permutation is somewhat complex.
Okay. You say your
Same as-
background is
same here
your
too. Yeah, it's based on the complexity of
You're actually correct. So factorial design is truly complex. So it's an example of a complex design. That's when you have you are looking at interaction effect. We will talk about that. So that makes it complex. So number 8, what is the main advantage of using repeated measures design? What will you consider as the main advantage? Faster statistical analysis, greater external validity, lower variability due to individual differences, simplified sampling procedure. Quickly. We have 2 more to go. People, no deal. D. Mustafa, why have you chosen D? Why are you convinced that the sampling procedure is simpler? Mustafa, unmute and talk to the mic.
Okay, I believe with that repeated it will give a person an idea of what is the way the research has been done earlier, so that makes it simpler for the person doing it.
Oh, sorry, it's not like that. The correct answer is C. So it's simply because the key statistical property we are interested in is the variability. You are interested in variability measures the spread, and when is small, then that implies your precision is high. So it's very much related to precision. But when the variability is high, then of course precision is very, very low. So we will talk about that hopefully. So the correct answer is C. The last but one, why are control groups important in experimental designs? Why are control groups? I've talked about control groups. Those are groups that you do not apply treatment to. So you can apply treatment to others. In other words, those groups, you leave them as they are, and then you see whether without them receiving the intervention or the treatment that you apply, whether they will make a difference, from the group that you apply treatment to. Again, we'll talk about that. So, which one is correct? The head test multiple dependent variable. They make data entry easier. They allow for comparison to isolate the effect of the independent variable. They reduce the need. I've even mentioned the answer. What's your response?
C.
C. So you got it. Finally, which statistical technique is commonly used to analyze repeated measures in design? which statistical technique is commonly used to analyze repeated measures designs? You can guess. There is no sin in guessing here. Yeah, no, ANOVA. What do you know about ANOVA? ANOVA means analysis of variance. Analysis. This is analysis of variance. Yes. The correct answer is A. Clap for yourself. Everybody, clap for yourself. No. So even without this lecture, you are able to attempt the multiple choice questions. That shows you are brilliant. So let's go to what we intend to be able to learn today, if time permits. One, we want to be able to differentiate between basic and when we talk about advanced experimental design. What makes some designs basic? What makes some advanced? Then we are interested in the components, the key components of experimental design, like control groups, which we'll talk about, and then randomization, which I referred to the other time. They are key component of any, there will be randomization. Randomization is when you assign subjects randomly to the groups. So if you create two groups in this class, group A, group B, and then you will now, if you ask everybody, go to the group you like, then some friends will go to the same group. So randomization prevents, randomization prevents the possibility of assigning in a systematic manner, in a non-random manner. The other major component is sorry, just a minute. So the other key component is the concept of manipulation, which I told you earlier should not be interpreted in a corrupt perspective, to mean maybe you are trying to do abracadabra or magic. No, that is not the sense in which is being used here. Is in the sense in which you are able to change the independent variable, the way you are able to choose what level or the kind of input that you bring into the experiment. Then we want to at least be able to see how we can apply factorial. Those are relatively advanced designs. We will give examples of energy applications, and then we will recognize the challenges in that you are likely to encounter if you choose to use experimental design in your study. There is no design that is not associated with one challenges or the other. So this is what we hope to achieve. So to start with, what is experimental design? There are 4 basic elements that help us to say that an experiment, a study follows an experimental design. One is the structure of the plan, how you want to test the cause and effect relationship. I've told you, you could have Y as the effect, and then of course you have X1, X2, and so on as the causes. So they cause, so you could have, this is Y, is causing X. Sorry, that should be the other way around. So you have this, you have this. So this one is X1 is causing this. This one is X2 is causing this, right? So this is Y. So if Y is your energy consumption, the amount of energy you are consuming, what are the things that can cause it? Your income can cause it, right? What other thing can cause your consumption pattern to change? Who is telling me? Who is telling me? Quickly, let's contribute. Apart from income, what else can cause change in energy consumption?
Maybe taste.
No,
Energy consumption.
I
It's weather.
expect you to talk about price. I expect you to talk about
weather.
price.
Tariff. What of weather?
I need weather, well, everything. But now, currently, before now, I used to fill my tank. Only those people in this class is only you people can fill your tank now. I've been doing some, in fact, maybe I can. I've been doing some very serious study. Are you able to see my screen?
Yes, sir.
Yes, sir.
Let me show you something to this is how I've been monitoring my fuel consumption for some time. Right. This is how I've been monitoring my fuel consumption for some time. This thing is okay. Can you see this dashboard?
Yes, sir.
Okay. So this is my own way. I started since December 2024. So it's interesting. Cumulatively since December 2024, I've spent 660,513 naira 90 kobo fueling my car. And you can see the cumulative total cost of fuel I purchase over time. Each time you see the volume, the, the volume of fuel in liters that I could purchase. Well, my own case is even better. Let me show you another colleague of mine. Yeah, somebody, I shall go and comment. Maybe because I'm a bit better. This person, often is to buy 20 liters, 23 liters. Yes, Ashegun, is it by error or okay, Ashegun, you have the floor. Let me take your.
Yeah. So, sir, I want to ask a question. How do you measure the discrepancies in price as time goes on? At some point in time, the price per liter differ. So there was a time it was being sold at 800. Now it is now 900. How do you put that variable in this
No, the
particular
price
situation?
has nothing to do with the total amount you spend. What I'm doing is each time I refuel, so I record the total cost of fueling as well as the volume of liters that I bought. But I also take note of the price. So I monitor the price. For instance, in my own, you will see that most often I use UI fuel filling station. And this has been the range, or this is the corn oil in UI. And on many occasions, it's been ranging between 900 and 933 naira. And you can also see each time before I refuel or in between refueling periods, I also take note of the estimated distance driven. So if I refuel today, I record the odometer and track the kilometers until the next time I refuel. So I'm able to link the volume to the kilometer and also understand the fuel efficiency. Anyway, I'm just giving you this. That may be subject for another day. But I'm encouraging everybody to take time to record some of these things that you take for granted and see patterns. You are in energy, and nobody is alive without consuming energy. So you can also monitor your energy consumption pattern, understand your behavior before you even understand other people's behavior. So let's come back here. So experimental designs are structured in a way to test cause and effect relationship. So 2, experimental designs involve the manipulation of one or more independent variables. So here I can manipulate. In this study, I can say, okay, if I increase the income when the price is constant, what will happen to the consumption? you can come and do that experiment with me. Increase my income, keep the price constant, and see whether I will not go and buy new appliances, buy new fridge, buy new this thing, no. So once the income start coming and the price is not changing, I go for more, more energy consuming stuff. So when you do that, you are testing the cause and effect. As you tamper with the cause, you are trying to see the effect. So there are one or more independent variables that you constantly manipulate. So manipulation simply means you are changing them. As you change them, you observe your Y, to see how it changes. Another major thing that defines experimental design is observation of effects of independent variables. You must constantly observe your Y. So as you are changing this, you will be observing this. If you hold the income again and you now change the price, then you will be monitoring this. So all of this will make interesting study if you can, only that it may be costly, and then for people to volunteer themselves and so on. And the thing is that, again, if people know that you are actually studying them, they can misbehave. But there are different ways of doing these things. So the key elements are control, which means you will have groups that will not receive the treatment. You will have group that will receive the treatment. The group that does not receive the treatment is the control group. Then randomization is about how you assign individuals, households, firms, or any economic agent to the different groups that you are studying. Then replication is being able to repeat the experiment several times. Replication enables you to ensure accuracy and validity of your results. So, and I have examples of experimental designs in energy research. So one of them, for instance, if you are using pre-test, post-test, randomized control trial, then this is a typical study that you can do, assessing the effect of solar panel installation on household energy expenditure in northern Nigeria. And the design will involve two groups. So one group will be regarded as the treatment group, another will be the control group. And then you will now carry out pre and post intervention survey. The treatment group will be those that you possibly install the solar panel in their houses, and the control group will be those that you have not installed a solar panel in their houses. Then you will now be monitoring the household energy expenditure in those selected households. So this is pre-test, post-test. Before you intervene, before you put the solar panel, you monitor their energy consumption, expenditure. After the experiment, that is, after you have conducted, you have grouped them into two. Those that will be given solar panel, those that will not be given solar panel, and then you monitor again their energy consumption. After the experiment, you now do the post-intervention data collection. So you compare the pre and then the post. I hope that explanation is clear. If it is clear, type yes. Quickly, 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 quickly. Nobody has typed yes. Looking for where Y is on the computer. Yes, finally Terry got the keyboard for yes. Denied now. Others are still looking for where the Y is on the keyboard, where the E is. Emmanuel finally, yes, someone here finally got. Okay, so let's talk about the factorial design, maybe 2 by 2. No, in this factorial, you evaluate. Example of a study that you can call factorial design is when you evaluate the combined effect of energy saving awareness and electricity subsidies on usage behavior. So it's a very complex study, but the issue now is that you look at energy saving awareness. You want to study whether the knowledge or the awareness about of energy saving combined with the knowledge with the electricity subsidy, whether the effect together affect the usage of electricity. That's what that study is all about. So this is where interaction effect comes in. So you are able to see how energy saving, that knowledge and subsidy combined, affect usage. So you can have 4 groups that will receive different combinations of the interventions. So those who will have those with energy saving with subsidy, that will be one group. Those without awareness, energy saving awareness, but also with subsidy, that will be another group combination. Those with energy saving no energy saving awareness, but with subsidy, that's another group. Those with no energy saving awareness and also no subsidy. So you have 4 groups, and you now study these groups. That's why we say it's complicated, because it's looking at the interaction. Those with energy saving awareness and those with subsidy, one group. Those with energy saving awareness but no subsidy, that's another group. Those without energy saving awareness but with electricity subsidy, That's another group. Those without energy saving awareness and no electricity subsidy. That's another group. So that allows you to study the interaction effect. If you understand, clap for yourself. Clap for yourself. It's difficult. I didn't say clap for me, clap for yourself. Junaid, Kwayom. Okay, yes, Oreoluwa. Okay, let's go to the quasi-experimental difference in difference. A typical example is if you are studying impact of new electricity tariff on low-income households in 2 states. One is reformed, the other is not. So we call this one quasi. So you just have 2 groups. So the way it is designed is that you have to carry out pre and post policy data, and there will be no random assignment. So that's one major reason why it's quasi. Even though you have the groups, but the assignment of the household is not random, and usually it's difficult to do that in practice. So this is quasi. Then we have repeated measures design. And one study example is if you are monitoring indoor air quality across different cooking fuels used weekly by the same household. Why is it repeated? So looking at the study, you have a set of households that will participate in the experiment. A fixed set of households, the same household. So take every member of this class as a household participating. So all of us will be involved. So my household, your household, everyone will be there. Now, the study is going to now monitor indoor air quality across the different cooking fuels. So maybe my cooking fuel is kerosene. Your cooking fuel is gas. Another cooking fuel is firewood, and so on like that. So we will now, with our different cooking fuels, this researcher will be coming every day or weekly, or in this illustration is going to be weekly, and then start and take measurement of the air quality in the building, in the house. So the researcher will take the measurement of the indoor air quality in the sitting room, and if you allow, in the bedroom. Go to my own house, since I use gas. Since you use kerosene, it will also come to. So it will do that week 1, week 2, week 3, week 4 for everybody. You can imagine the amount of data that will be collected. If you understand, clap for yourself. If that study is interesting, nobody is clapping. Emmanuel Ode, Terry, are you there?
Yes, sir.
Tell me what you understand.
Just like what you said,
Yes.
if you want to conduct a research on the air quality of different cooking fuels in
Yes.
different homes, taking our class as a case study,
Yes.
every single individual here being a household.
Yes.
So if I cook with gas,
yes,
I will come take the quality of the air for today.
yes.
If Labake cooks with firewood, I'll take the quality of air of firewood.
Indoor air, indoor, not outdoor air. So how is monitoring the kind of
something like charcoal stove. Hello, can you hear me?
Yes.
Like charcoal stove, there are some charcoal stove they use indoors.
Uh-huh.
I will test the air quality. If Tone cooks with a halogen stove, I'll take the air quality and compile the data.
Exactly. So what do you think about this kind of study? What will you think will be, what do you think about this kind of study?
Well, I see it as a comparative analysis.
What do you mean by comparative analysis?
Comparative means you're comparing the air quality of each cooking well.
Yeah. So you will have a very rich information about the impact of, each of these cooking methods. Each of these cooking fuels that you use, and how is affecting the health, even though the focus here is not even about the health, but just looking at the quality of the hair. Another medical, those who have interest in medical stuff can now take it off from there. I hope you are conceptualizing, thinking about how you can develop very unique research design that we've never had in this center. Emmanuel Ode.
Yes, sir. Good evening, Prof.
Good evening, sir.
Okay. Prior to this time, I was from what I've known, I was thinking experimental research design is purely for sciences and not social sciences. Like the quasi experimental is what is used for social sciences, but like I want to really get, is this experimental, like shouldn't it be purely for sciences, like when you want to test chemicals or something, but not human beings, like when you want to carry out experiments on chemicals or drugs, yes, okay, yes, then are not really for humans, like for social sciences.
Yeah, that's what we are trying to prove, that is not, these designs are not meant for pure sciences alone. That it's a cross-cutting design for different fields in law, in energy, only that I'm not teaching law. But that's why I'm focusing more. If I'm to teach in education, these same designs, I will teach them and apply it to education stuff. If I'm teaching in medical, if I'm teaching medical students, I will also show them how they can design, use all these techniques, and give examples peculiar to their field. So it's it's completely erroneous, to think that these designs are meant for sciences or for pure sciences only. Is that okay?
Yes, sir.
Good. And that's why I would love most of you to show, due diligence in the way you design your study. Let's have something, different from what we used to have. People go to NAREC, going to CBN, going to collect data and begin to do stuff where you can carry out experiments. And you will enjoy your own. That, of course, is, yes, Terry again.
Sir, well, as per designing a research approach,
yeah.
Well, I was thinking we should be looking at a viable field of research that would possibly have a direct, even indirect effect on our economy in relation to energy.
Yeah.
So I also believe that most of these research are actually based on data that is available already, mostly from the Bureau of Statistics and every statistical establishment out there.
No, if I get you right, are you saying all the ones I've been talking about are based on data available with MBS?
No, not really. Most of those data were collected from the field by maybe some other persons.
Those are not experimental design. They simply conduct survey, or they are not, they are not they are not designed in form of experiment.
Okay, what I'm actually asking is what would be the possible economic viability of within a short while of these designs, experimental design research fields.
Wow, look at the one we are talking about. Even this number 4, we are looking at the industrial quality. Yeah. So if somebody is convinced that the LPG use, that the air quality is better than all the other ones, and you want to now set up a business, will you go and promote kerosene to these kind of people who are interested in better air quality? Terry.
You're right, Prof. You're right. Thank you.
So there are those who are resourceful enough to say, okay, I want better. How many years am I living on that? If better air quality will guarantee me.
But Prof, most of these research fields are capital intensive.
That's another issue you are bringing in.
Especially for a student.
Today we are not talking about
without sponsorship.
We are not talking about how to fund research. That's not our discussion out now. Bringing the issue of funding is out of context at the moment. When we get to the issue of funding, meanwhile, let me announce to the class that I just wrote a manual which I think will be helpful to the class. This is the book, the manual. We're not yet in form of a book, but this is called computational. I didn't tell you, I forgot. Quantitative research methods, and is dedicated to CP students in particular. Printed copies will be available from next week if you are interested. So it's good to have it handy, have it in your library. Introduction to quantitative research, research problem, objective hypothesis, research design, different, I have, I talk also about how you clean your data, descriptive statistics, visualization, inferential regression. So quite a lot of stuff, and a little bit of introduction to some of the tools. We just talk about difference in difference, propensity score matching. It's 5,000 naira, but if you had several zeros, nobody will query. But the takeaway price is 5K. Then you have a little bit of how you can use some of the softwares, not so deep, but at least provide guide. And you have discussion around AI supported research workflow, how you can use AI, and the cautions and ethical issues that you need to be aware of, the concept of originality, documentation, and reproducibility, how you can, quite a few stuff, just briefly. So it's like key points. So you have altogether about 80 something pages. So it's 5K. Hopefully by next week you can pick a copy. It's just a course manual. Sorry for digressing. I will have forgotten. Okay, so let's move on. Will it be available in the department? Yes, maybe I will drop some in the department. But I've not decided. It's better you even come to my office rather than department, if you don't mind. At least that will help me to see you. So split plot design. Another good example is a community level smart grid training, and household level solar subsidy. So the community level smart grid training, the village will be the main plot, which will be regarded as the main, and then within the community, that's where you are also picking the household, and introducing solar subsidy. That will be regarded as the subplot. So this kind of design sometimes is called nested design, or arachaica. So the community is the bigger group, but within the community you also have the households. So that's another level, but nested within the community. So that's why these ones are called advanced design. So, but there's no way we can treat all of this, exhaustively. So what are the characteristics of true experiments? I've mentioned them earlier. One, there will be there will be randomization in the way the participants, the household, the firms, will be assigned to their respective groups. There will be a control group. Those are those that will not receive the treatment. There will be the treatment group. Those are those that will receive the treatment. So when I talk about treatment here, in the medical palace, maybe you just develop a new drug, and then you want to test the efficacy of this drug. You can have two groups. Group that will not receive, you give them what we call placebo, and then the other group will be the one that will receive the new drug. And then over time, you see how they react, and you analyze and see whether the 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 drug is effective, in treating whatever ailment that you develop it for. The same mentality is what we bring into experimental designs. So there will be manipulation of the independent variable. Olajumoke, are you still with us? You are too quiet now. Olajumoke? Wow. I've not heard you talking. Is the internet? Oh, okay. So we have the pretest. Pretest is the test that you carry out before the intervention. And then the post-test is the test that you carry out after the intervention. So experiments are characterized by this. There are experiments that you don't have pre-test, but you can have post-test. There are experiments that you have both pre-test and post-test. So example of a typical experiment is when you want to answer question like, does solar panel installation reduce kerosene spending? You can use experiment to study this. So you can now have a group of households that you can call the treatment household, and then you give them solar panel, or if you don't have money for solar panel, let's say you want to see those roadside hawkers, those who sell this thing. Instead of them using firewood, those who sell Bolly and co, you can have a group that you give a gas cooker. I don't know if they use gas cooker for Bolly or so. Anyway, you have a group, and then another group that will not receive the treatment, and then you are able to compare the two groups. So when we talk about the characteristics of true experiment, randomness, control versus treatment, manipulation is allowed in experiment, then is characterized by pre-test and post-test. So these are basic features of true experiment. So, of course, we will quickly go through this. We've talked about them before. So these are 4 basic experimental designs. The first one, pre-test, post-test, control group design. The second one, no pre-test, but only post-test, control group design. The third one, Solomon 4 group design. And then the fourth one, randomized control trial. These are 4. Time is not our friends, but let's see how we could go quickly. So we take them one at a time, pre-test, post-test, control group design. For this particular design, this first step is the selection of the participants. So you will need to recruit the participants, and then you will assign them participants that will be in the control and the participant that will be in the treatment groups. So once you have done that, before you introduce the intervention, you are going to carry out the pretest. No, you have not yet introduced anything to them, but you will simply collect data about what you are looking for. So the data will then be like a baseline, maybe their energy usage, before. So, and that will be for the two groups anyway. So you will measure the dependent variable for both groups, before the intervention. Then you will now bring your intervention, which means it could be that you bring solar panels, it could be that you introduce, you subsidize, whatever intervention that you want to introduce, you introduce that. So you apply. Remember, you have done pretest. Then after the intervention, you carry out the post-test. So which means you will now go back again and measure the whatever you measure in the dependent variable, and then you will now do comparison of what you have in the pre and what you have in the post. This approach, you use the difference in differences approach. It's a statistical technique. So the purpose is that it helps you to establish causality, which you cannot establish in regression, which we discussed, or correlation, which we discussed in the last class. The next one is post-test only. As we notice, okay, before I go, any question on pre-test, post-test? Any question quickly? Oluwa Lowo, you've not spoken today. What's the problem? Oluwa Lowo. It's not in the class. It's not in the class. Gideon.
Good evening, Prof.
Good evening.
I'm with you, sir.
Yes, I want to be sure you are with me.
I'm with
Any
you, sir.
question? Any question so far?
No question for now, sir.
Everything is clear.
Not exactly, but
I shouldn't worry myself.
The question will come
when it is time.
Yes, sir.
Okay, let's go to post-test only control groups. So the process for this is that you start by recruiting and also by assigning the participants randomly. So you look for volunteers, or you engage them, ask for their consent to participate. So once they give their consent, you assign them randomly and say, no, you will be in control group, you will be in treatment group. You may not even tell them, because but you know them, and then you bring your intervention. Your intervention could be you introduce subsidy, you do whatever. Then but the intervention will only be applied to the treatment group. So the control group will not receive any intervention, or you give them what we call placebo, something that will look like the real drug, but it has no effect. It's just like it has no effect. But yes, somebody wants to say something. Okay. So after you have introduced the intervention to the control, and then you avoid giving to the you introduce the intervention to the treatment group and withdraw it or not apply it to the control group, then you now conduct the post-test measurement, which will involve measuring the dependent variable, your target variable, in both groups after the intervention. Then you now compare and you carry out your analysis. The analysis involves you evaluating the different outcomes between the two groups, and that will give you what we call the treatment effect, whether whether the intervention actually make a difference or not. This design is useful when a pretest is impractical. There are situations where it's practically difficult, if not impossible, to carry out pretest. Or if you do the pretest, it can again influence the behavior subsequently. Now, the next one is Solomon 4. I'm sure most of you will be hearing this for the first time. If you are hearing this for the first time, type yes. Solomon 4 group process design. Solomon 4 group. Okay. Omolabake is hearing this for the first time. Everybody. Is there any Solomon in this class? Solomon. No Solomon. So, no Solomon. No Solomon. Okay, everybody. So, which means if I have the opportunity to set your question, I will bring question from this particular place. I will ask you to describe Solomon 4 group design and give me possible study, design and energy study to implement Solomon 4 group design. So if you are looking for Orijo, that's one for you. Every student wants it. Okay. The process here starts from assigning treatments randomly into 4 groups. So there will be group 1, group 2, group 3, group 4. The group 1, you are going to do pretest for them. Then you will apply treatment. Then you will do post-test. So it's like the first thing that we did here, pretest, post-test, control. So it's like bringing this into Solomon 4. That's what this one is doing. Then group 2 is going to do precisely what there will be a pretest, there will be no treatment, there will be a post-test. So there will be a pretest, there will be no treatment, there will be a post-test. So what is missing is that we are not, in fact, the way they are when we carry out pretest is the way they will be when we carry out post-test. So the third group will receive treatment, there will be no pretest. So it's just this one that is coming in the third place. So no pre-test, but there is post-test. So we've talked about this. Then the third group is that there will be no treatment at all. No pre-test, no treatment, no pre-test, no treatment. But again, there will be post-test. So this is what we call Solomon 4. The way to remember is that there will be 4 groups, and subjects will be assigned randomly to the 4 groups. But the measurement and treatment would differ across the groups. In group 1, measurement before treatment, treatment will follow, measurement after treatment. In group 2, pre-test, there will be no treatment, there will be post-test. Group 4, there will be no pre-test, there will be treatment, there will be post-test. And finally, group 4, no pre-test, no treatment, but there will be post-test. Clap for yourself. That's how it goes. Just a minute.
Sir, we cannot hear you.
He's on call. He's on call.
He's on call now.
I'm so sorry. It's just that I needed to take it. So sorry for that. So, I was saying that the purpose of each group, the group 1 and 2 is to help assess the effect of pretesting. So you notice that you have pretest in 1 and 2. So we are assessing the effect of pretesting. In 1 and 3. In 1 and 3, yes, 1 and 3, we are interested in testing the treatment effect with or without pretest. So, and in group 4, it's like a pure control. So, after that, measurement will be done, comparison will be done, and then we'll be able to isolate both treatment and testing effects. The strength controls for testing bias and ensure internal validity. We are almost done. The last one, I will leave the rest to you, so we can finish. So the randomized control trial involves you recruit the participant, you define the target population, you make sure you recruit a representative sample from the target population. You will assign them randomly to treatment group and also to control group. and then you administer the intervention, which could be in form of policy, program, product, to the treatment group only. And then you measure the outcomes after the intervention. That's why it's post-test. And then you carry out analysis and draw your inference. You are able to estimate the causal effect. So the randomized control treatment or control trials, they are considered the gold standard for causal inference in policy and impact evaluation. So this is where we are going to stop. There are other interesting discussions, but time will not allow us. But the summary, the pitfalls in experimental research. If you do not do randomization, that may create bias. So that could lead to bias. Attrition may also create bias when participants suddenly decline to participate at the middle of the experiment. Then there could be what we call confounding, from what is causing the change may be something else or something that you are not even able to see or what you are able to take note. So you can have the confounding problem that is uncontrollable. There could be contamination across groups. Contamination is not like poison, but if they are communicating among themselves, that could be regarded as contamination. I'm part of that study. Let's we have to be paid. We have to be paid, and there is a way they decide to alter the experiment, and bring distortions and so on. So there could be ethical concerns, denying access to services or gender sensitivities and all of that may come in. Finally, this is a summary, and which must be taken away. You must take this away. One, experimental designs are crucial for testing causal hypotheses. When you want to test cause-effect relationship, then go for experimental. Basic designs, that is where we talk about descriptive and correlational analysis. They provide structure, thus the background or the preliminaries. But advanced designs enhance the depth of your study. So when you are ready to embark on your research, then you have to choose based on context, ethics, resources. Thank you very much. And before I say bye, any question? Sorry, I've exceeded your time by 2 minutes. But this is where we are going to stop the lecture. Thank you very much. Any question, ladies and gentlemen? The class is quiet. Any question, any comment?
Not from my end, no, sir.
Not from your hand. Nobody is commenting. Okay. Since there are no comments, it's like only the name is here, the body is not here, the voice is not here, even the air The eyes are not here. Nothing else is here. So I'm also closing my eyes and closing my video. See you next time. Stay well, stay blessed, take care of yourself. Bye.
Thank you, sir. Bye,
Thank you
sir.
so much, sir.
Thank you, bro.
Thank you, sir.